Good afternoon, everyone. My name's Will, and I'm half of the co-founding and directing of ScanLAB. I'm actually also going to introduce to you the rest of the team, because they're a lovely bunch. We're, I guess, 50-50, roughly, developers and computer scientists and super nerds. And the other half are designers, architects, artists, and just curious people. So we're kind of at this really lovely crossroad between technology and art. It ends up in lots of funny arguments about how to finish stuff and make things and put things together, but we also end up just chatting about weird things like Bitcoin over lunch. So it's a funny mix. It's good, though. So that's the team. I'm just going to talk a little bit about how laser scanning came about and a quick history lesson. Naturally, as all good things come from NASA, laser scanning was really kind of first put into good use by them. This is actually a modern satellite which is able to track wind speeds and directions across the Earth. So it's incredibly fascinating technology. But it was first really kind of put to good use scanning the moon, and both for mapping and topology reasons of working out where to put the lunar landers, but also used on the Apollo lander itself, naturally having no atmosphere on the moon. As they were coming down to land, they needed to know how far they were off the surface, so just pinging singular measurements, tiny singular measurements per second allowed them obviously not to crash into the moon. And looking forward to the future and where we're going with scanning, all of our autonomous vehicles will rely really heavily on scanning devices, whether it's photogrammetric or whether it's laser like this. And there's an ironic moment here that the lasers that they started out using, which is on top of this car, is actually twice the value of the car that it's on. So there's a long way to go with being able to make this a usable piece of technology, but they're already beginning to take this from what is a mechanically spinning bunch of lasers down to a silicon level. So this will be going from $100,000 down to $100, and that will suddenly open up the whole way of thinking. And the other massive change here between what's happening on screen here and what we do is that this is about machines seeing the world. And a lot of what we do is based on how we like to use scanning as a sensor to see the world as humans, sort of augmenting our view of the world. And the other really big difference here is that this is working with time. Lots of our scanners take ages to do their scans, whether we're doing low range and it's a couple of minutes or really long range and it's several hours. It's a totally different world when you want to track moving objects and you need to have 10, 20, 60 frames per second. So the resolution, I'm sure, will change eventually, but for machines, the minimum amount of information to distinguish people is kind of their optimizational stream. So it's a different world. And then the other kind of side of that is being able to miniaturize it further and then or put that together with humans. And obviously for Google to expand their advertising real estate into people's homes beyond the street, this is a really important step for them. For us, I think it's a fascinating way of seeing the world, and it will probably be also form the backbone to lots of the ways that our digital world will be augmented with our physical. So being able to see those adverts or see things jump out behind walls, play games, it all relies on the technology which they're beginning to develop and optimize here. In terms of what sensors we have a little go with, this is some of the sensors and some of the data that we use when we presented with a really long range or a really massive site. So actually here we're using photos, we're using photogrammetry, which I'm sure you're all very familiar with. But the nice moment is when we're able to blend between data sets here as well. So our drone can take thousands of pictures of the landscape, but we can also go down on foot and scan that, and then we can merge those two data sets together. So it's a great way of suddenly taking what would take us months, we can do in an afternoon with a drone. So jumping up a scale with capture there. The other side of the scale is shrinking down and looking into objects. And this is CT scan data, the same CT scanner that you have in hospitals. And on this particular object, we've been able to sort of identify the internal structure there of the metal bar in this guy's head. This is actually one of the casts from Pompeii, one of the first really old objects. Tick. And although this actually threw up lots of really interesting arguments in Pompeii, especially with the superintendency, because they thought all of their casts that they had were originals, but clearly they weren't because there's lots of modern artifacts within the heads. So we got into trouble quite quickly there on that project. Looking at the talk, though, and the subject, I wanted to give a little intro to how ScanLAB first came about. And actually, it was Matt and I hiring an artist studio at the Slade School of Art in London, that we first started ScanLAB. And ScanLAB was a week that Matt and I decided to put together. And we were interested to take the terrestrial Faro scanner and see how far we could push it. And my preoccupation during my master's at the time in architecture was scanning the weather and being able to build architecture about the weather. So we started a whole series of experiments to see whether we could scan smoke, see whether we could scan water, and build weather up from it. So that we started out by making a fire in a MDF box in the middle of the Slade, which got us into no trouble at all at the time, but this image has since incriminated me several times, especially since we've covered the fire detectors on the ceiling in in paper, and this image proved that we did that. But we were also just amazed by the results of the scanner and being able to dig into the detail and all of the data that was normally removed from the scans. So if you think about how the scanners were first developed, they really came out of industry. People were really interested to understand oil rigs and car factory plants. And so measurement was really the key element of these scanners, being accurate and telling the truth. But as young architects interested in messing with things, we were far more interested in bending the truth, and actually how, as a medium, this is a whole new way of looking at the world. So we then also did a whole series of experiments, putting massive 8x4 sheets of mirrored acrylic in front of the scanner and distorting reflections of the walls and ceilings in front of the scanner. So the kind of bloom of data there to the right-hand side of the image is actually a reflection of the ceiling that the scanner is seeing in the mirror. But the scanner can't get the angle wrong. It knows exactly where it's looking and recording, but it can get the distance oh so horribly wrong. So you have this ability to really kind of mess with the scanner and start turning this whole world of truth on its head. And that really kind of was the sort of foundation from which we kind of grew our studio. I'm just going to turn this up gently. Oh, it didn't play. This is an animation that should play, but it hasn't. But is our project called Noise, and this is, for us, a really interesting experimentation into what happens when a scan goes off and what happens when you need to take all that data and turn it into something. So, like I was saying earlier, these are machines which need to be able to record space accurately and turn it into a model, but there are atmospheric aberrations and reflections and noise that is typically always recorded by the hardware, but is removed later by the software. So what we really wanted to do here was take all of that and put it back in and show you that world that the hardware sees in the first place and not what the software wants you to see afterwards. So it's obviously not very good for building accurate bridges and geometry, but for us it was a sort of fascinating insight into what's going on under the hood and looking inside what's going on with the scanner. So these are two scans taken in Germany, one over the river Spree and the other in Berlin Tempelhof airport. So the one on the left is in the airport. It's a huge, obviously, open space, and the range of the scanner there is about 150 meters, but we've shown you here data right up to 300 meters. So, it shouldn't be able to record the clouds or the sky. It shouldn't be able to see the end of the world turn into a lip and roll off. But all of that error and all of that unusualness is still always in there. I'm going to talk about now some of our other work, some of our kind of more commercially minded operations, and they all kind of span from a really sort of quite obvious side to the way scanning works, and some of it works with our heritage, but for us it's sometimes more about the relationships between spaces, and both as Matt and I being architects, that's kind of at the core of how we look and see the world. So this is obviously an enormously famous space, but when we get the chance to be able to go out there of the refectory there with the Last Supper, we can go out through the gift shop and then down through the courtyard and back round into the house that adjoins the painting, and actually reveal this really very beautiful but quite ugly life support system that the entire wall is sat on. So the steel structure, the humidity sensors, the gap movement sensors, the temperature sensors, these are all there keeping this entire system alive. And it's that relationship that sparks lots of very interesting projects within the studio, which have relationship to broadcasters and being able to use scanning to unravel spaces and put relationships that people might never have seen or understood before. So that kind of comes to a pinnacle with some of our work last year with the BBC.
Italy, I just love this country. The people, the places, a history that reaches back over 2,500 years.
From the birth of the Roman Empire, through the glories of the Middle Ages, to the flowering of the Renaissance, its achievements are just breathtaking. But behind its glorious facades, so much of that invention and creativity still remains invisible.
Look at that. I'm exploring 3 of my favorite Italian cities to discover how their hidden treasures played their part in the making of Italy and of Western civilization.
Using the latest 3D scanning technology, we'll reveal the secrets of how these cities made Italy a powerhouse of the Western world. Our 3D scans reveal a skeleton image of the tower. It can help us see how the medieval builders tried to correct the leak. First time, I can begin to see how Brunelleschi did it, and what a spectacular structure it is. I'll be working with historian Dr. Michael Scott to uncover the invisible layers of Italy's past. Our scanners will create a 3D model of the region, and I'll use virtual reality to get inside the scans.
Like, oh, wonderful, I can see completely 3D. It's dusting all around. This is Italy as you have never seen it before. Welcome to Italy's invisible cities.
So for us, apart from just producing the visuals, they're always quite an exciting way of adding in new technology. And for this one, we actually needed to be able to scan Venice. And without any roads from which we could scan from, we had all sorts of problems, but came to the rescue by Leica, who gave us one of their mobile scanners. So actually what we had done is bolted the scanner to a boat and decided to go driving around Venice to capture all the facades. But also the BBC are quite keen to kind of reach new audiences, and that's always exciting for us because it gives us the opportunity to kind of put things out in different ways. And always producing flat imagery, whether it be animation or stills from our data, is always sometimes a bit frustrating because really you want to be able to get back into that world in 3D. So we've had the opportunity to make some VR pieces with the BBC on Google Cardboard, and also to put at Arts Electronica a huge 8K projection in 3D. Both of which have spawned really interesting and sort of exciting conversations in the studio. And that kind of leads me into this project, which talks about transporting people to places they might not have seen or been able to go to. And this is a project that started a couple of years ago in Lesvos, and Matt had been out during the crisis in February in 2015 to witness some of the events. And we had the opportunity this year to put some of those events back into a gallery space for people to watch and engage with.
کردیم به سمت ایران داشت اومدیم. این جالبش اینجا بود که
So apart from the enormous technical challenge of trying to get millions and millions of points into virtual reality headsets, it was actually the sort of interaction with meat space and being able to stand on the landscape in which you were in, which was actually kind of one of the more profound parts of the project, which we found really rewarding. So, being able to go to those four places, but also root your feet in them was one of the really nice bits. I'm going to see, can I sneak in another one before, or are you going to tell me off? Yeah, quick one. Okay, cool. I just wanted to briefly mention the concept of cameras. One of the sort of rolling conversations in the studio is that we kind of promote 3D scanning as the evolution of the camera, which is a bit dangerous, especially in a crowd of people who are very intelligent. But in some ways it is, but in others it's not. And it was quite interesting here in this shoot because we'd had the set dresser, we had the costume design, the fashion design from Vivienne Westwood, you had the makeup artist, we had the director. This is huge shoot here on this location, and we wanted to, take these kind of very beautiful portraits, but as soon as we started and everyone was ready and in position, the director was like, right, great, take the picture, let's have a look, and sort of expecting it to sort of appear on the laptop as they would normally work. But at that point, we had to tell them, seriously, no, we need to clear this set. No one's allowed in here whilst we're scanning. So it added an air of mystery to what was going on, which was interesting. But it sort of turned the whole traditional case of a photo shoot on its head, and I think they found that really difficult to deal with. And the other element for us is obviously that these scans take ages. This scan was about 15 minutes, so the models have to stay very still, and then we end up resorting back to the similar kind of positions in which Victorian photography was taken, so the sort of really wooden pose and sticking a broomstick down your back. So there's funny analogies like that going on all over the place. But for us, we also wanted to push that analogy a little bit further and see whether we could also manipulate the same ideas about shutter and about moving the negative and the person at the same time. So we've had a recent project with Nike, just as a simple workshop with them, but experimenting in moving the scanner and the person and all at the same time and twisting it, which kind of got some really beautiful results. So the simple analogy is, at the start of or at the finishing line, of lots of races, you'll have a very similar camera. So you're recording time from left to right as well as space. But if you move that camera whilst you're also recording, you start distorting the space and kind of really messing with people's heads. And the last one is that being able to then take that out of the room and take that to the city and add all of that complexity onto that as well.
Thanks. Thank you.
Sorry.
Does anyone have any questions or comments? We have time for maybe one. So right here. I can't even hear you actually, so let's, because
I think I
can
got
hear,
your
but-
question, but do it again.
Okay. So I just wanted to ask in a very open-ended way, what was the artistic intent with the project scanning in Lesbos, and also when you made the comparison between the 3D scanner and the camera, because obviously there's been a lot of also exhibitions showing photography from there. What you thought was that you were trying to do differently? I'm supposing.
Well, I think the Lesbos thing could be quite simple in the fact that it's, in our minds, viewed as journalism in a sense, taking people to places they couldn't go. I think the artistic intent is therefore slightly simpler. There's not a massive statement that we were making there, and we'd love to take it to other places and bring people to that as well. So the installation side of things and the collaboration with some of the team there from the Baltic and from the Embassy of the Displaced, who we'd worked with the project as well, is very much to highlight the entire issue of the refugees in Lesbos and that bigger part of the story. But I don't think we were really placed politically to be able to make specific comments. I think we like to allow people to make their own decisions up about things, and merely to present the world, as a doppelganger that we are digitizing and giving to people.
Okay, great. Thanks. That's all the time we have. So now it's time for a coffee break. See you back here at 3:30 for Ora et Labora, the next panel. Thanks.
Thank you.